Welcome to 2.5 Polygons and Convexity. We're actually going to start right away on objective number 2. So concave sets always have some points that can't be connected by a segment without leaving the set. To have this shape, I am going to put 2 points in there where the segment has to leave the set or be on the exterior of the shape we have. You thought I forgot the funny, didn't you? Okay, so we're going to talk about how this angle is a concave set. Remember that the angle is different than the interior of the angle. First of all, it's not closed, so we can't really talk about anything other than concave. So if I drew 2 points and then I connect them, they are not, the green part of that segment is not on the angle. It's just on the interior instead. Okay, so definition of convex is a set has property that has 2 points determine a segment contained in the set. So if I can draw segments only inside a figure, then it's convex. And basically concave is anything that's not convex. Now how I remember this is the word cave. If it has an indent like a cave, that means that I can go inside it at some point from the exterior, then I have points that are not convex. So let's practice here. The star. Can I draw a segment that is where the 2 points, the two endpoints of the segment are interior to the figure, but the segment's on the exterior? Of course. I can do it on this figure, and I can do it on this figure. So these are all concave. These are all convex. Every single segment that I draw has to stay on the interior of the figure. Okay, so now we're talking about polygons. Polygons are a simple closed curve that consist only of segments. So it's still considered a simple closed curve, but there aren't actually any curved lines. So a side of a polygon is one of those segments. And then a vertex is the endpoints of the sides. So where 2 sides meet, you're going to have a point that is called a vertex. And then if you have a vertex, you have an angle. And the angle has 2 properties. It's the vertex of the polygon and it's the vertex of the angle inside the polygon. Okay, so a polygonal curve doesn't mean it's closed or not closed. Okay, it can be both, and it can also be simple or not simple. So let's look at some examples of that. The first figure on the top left, it looks like a square and a rectangle. Do you notice that it goes over itself? So this is considered what kind of curve? If you remember, it's a not simple curve, but it's also polygonal because you notice there aren't any official curved lines. So then the top right, you notice it's open, right? So this is a not closed polygonal curve. And at the bottom, we've got our regular closed curve. This is not convex, right? It is a concave polygon. Okay, so polygonal region is just the polygon and it's an interior. So we have another example here. We can classify these polygonal regions as convex or concave. So I want you to write down on your notes right now A, B, C, D, and I want you to go ahead and classify them. So push pause, classify them, and then check your answer. So A and D are the only ones that are concave. Okay, so the rest of these next few slides are going to be where I give you the number of sides and the name of the polygon. Now we've already talked about triangles, so we know it's a polygon with 3 sides. But we're going to talk about all the way up to 12 sides. And so I'm going to click kind of fast, so feel free to pause or rewind as needed. Okay, an equilateral polygon is a polygon where all the sides have exactly the same length. So if we're talking about a quadrilateral and you think of something that has 4 sides but they're all the same length, you would think of something like a square or even a rhombus. They have all the same length. Equiangular is a convex polygon in which all the angles have the same degree measure. Again, I can talk about a square because they all have 90-degree angles, and I can also talk about a rectangle. Now, rectangle is not equilateral, but it is equiangular. They all are 90-degree angles. And then I can talk about a regular polygon, which means it's both equiangular and equilateral, and that means the only quadrilateral that is both is a square. It is both equilateral and equiangular. And diagonals is when you connect 2 vertices, but they're not the side of a polygon. So we're going to talk more about diagonals later. Okay, so the interior of a convex polygon is the intersection, remember what intersection means, of the interiors of its angles. And then of course the exterior is the opposite. Okay? Okay, and this particular lesson, I want you to go ahead and do an open whisk summary. So it's at minimum 3 sentences to describe the overview of the lesson. You're still going to email it to me, but you will not receive a reply. Okay, and I will see you in class.